This question is about forces. It says the diagram shows an air track that can be used to investigate motion. It says that air comes out through a series of small holes, you can see these here in the diagram, in the air track. And then a small glider, this thing here, floats on a cushion of air. Now often we use this sort of thing to investigate collisions, so we might put another glider just next to here, and then we can look at whether momentum is conserved. But this question isn't about momentum, so don't get tricked by the diagram and the experiment. You know, keep things simple by carefully reading the information given to you. Part A, part 1, says the diagram below shows the glider at rest. So don't forget that rest means stationary on the air track. Complete the diagram to show the forces acting on the glider and label the forces. One force arrow has been drawn for you. So the first thing is that we've got a force acting upwards, and this is the force provided by the air pushing on the glider. Now, this happens with aeroplanes and gliders that fly through the air, and this is the force that we call lift. Now, you'd also get the mark if you said normal reaction force, but lift is more appropriate here because we're talking about a force being provided by air. Now, because it's at rest, we need to have another force that's balancing this force. So it must be acting down, and our arrow should be the same length as the arrow for lift. Now, if we've got a force acting down, then it's got to be weight. Now, there's 3 marks here, one for writing lift here, one for labeling this with weight, and one for making sure that the arrows are equal and opposite. Part 2 says explain what effect the cushion of air has on the movement of the glider. Well, because there's no contact between the glider and the track, there's going to be very little friction, and that is what allows the glider to move along at a nearly constant speed. You're not going to see much reduction in speed over the length of the track. So the lack of friction, 1 mark, means the speed remains almost constant. Part B. 2 light gates connected to a data logger are placed above the air track so that the card will pass through them. So here we can see these 2 light gates, and the card's going to pass through them as the glider moves along the track. It says that the length of the card is 8.3 centimetres, and it says the card takes 314 milliseconds to pass through the first light gate. It asks us to state the relationship between average speed, distance moved, and time taken. And this is probably the one question that every single student in the whole country is going to be able to answer. Speed equals distance divided by time. Then it asks us to calculate the average speed of the car as it passes through the first light gate. Now, some of the better students get a bit confused by this because they think, well, I've not been given anything about the car, I've just been given this details about the card. That doesn't matter because the card is connected to the car and it's not moving relative to the car. So you can treat them as one and the same thing. The reason this is tricky is because they've given you some values with centimetres rather than metres, which in this case is actually fine because it wants the answer in centimetres per second. Now the nasty thing they've done is they've given you a time in milliseconds. So you've got to remember to divide that milliseconds by 1,000 to convert your answer to seconds, because that's how they want the speed. So speed equals distance divided by time. The distance is 8.3 centimetres. The time we've got to convert into seconds, so it's going to be 0.314 seconds. We put that into the calculator and we're going to get 26.4 or 26 centimetres per second. Then it says, state the time taken for the car to pass through the second light gate. Now, we said that this allows the car to travel at constant speed. So if it took 314 milliseconds to pass through the first light gate, then as it states, it's moving at constant speed, the speed isn't going to change. So it's also going to be 314 millisecond through the next gate.